factor of 2 and 5?
Well, don't go there yet.
Oh,
I'm trying to build up there. So a terminating decimal, a simple one would be 0.1. Why is it terminate? Because it stopped. Right? Okay, I like it. And what is this as a fraction? 1/10. So if I have any decimal, any decimal that stops, couldn't I figure out what the bottom is? And watch, here's the quick way. Isn't this one place with 1 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? Every place over is another factor of 10. So the bottom has to be a multiple of 10. So what's the only factors it can have in it then? What's in 10? 2s and 5s. So 1/2, what is that as a decimal? But is the bottom 10? No. But I can make it 10. So as long as that would be 0.5, right? So as long as the bottom has only 2s or 5s, any combination of 2s and 5s, it's terminating. So will 1/8, will that be a terminating decimal? What's 8 made of?
2.
Only 2s. 2 times 2 times 2. So it's terminating because I can give it 3 5s. I really want this to make sense. If I had a factor of 3 on the bottom, could I ever make that 10 or 100 or 1,000 or any? No, I can't, because 3 doesn't go into any multiple of 10 or any. Let me be careful. Any number of 10s, 10, 100, 1,000. Are you guys kind of with me? That was the whole theorem about that. So some of you guys said, since it has 2s and 5s in it, no, right? Doesn't this have? Oh, there's a lot of shit. Doesn't 1/15 have a 5 in it on the bottom? It does, right? Somebody have a calculator? What's 1 divided by 15?
0.6666666.
Oh shit. I think it's 0.06.
Well, yeah.
All right. But you got it.
There you go.
You guys kind of with it? So that's obviously, is that going to terminate? That's the repeating one, isn't it?
Yeah.
So why didn't this terminate? Because it has a 5 in it, Jeff. You just said 5. We're 5, Jeff, but it also has a frickin' 3 in it, so that's not going to work. It can only have 2s or 5s. So if I give you something like over 640, how do you show me that's going to be terminating? What do you do with 640? Break it down. No LCD, but just prime factor that bad boy. Show that it only has 2s and 5s. Is that cool? Real quick before you guys get that? Okay. Yeah.
So we would just like show you by like dividing the 240?
Yeah, you can just break it up. 64 times 10. Blah, 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 blah. Make sure get all the way to its DNA and show it only's got 2s and 5s. Okay. I like it. Anything else?
Okay, so it stops.
I don't think anybody got
Does it stop
the
at
second
the-
bonus.
I'll try it.
Anybody got the first bonus either?
The first?
But don't look at the bonuses, don't worry.
We had just discussed that before the class or before the test.
Yeah.
And I was like, oh,
But I made it, I gave it
Yeah.
an extra 6 in there just
Yeah,
to make
that
it
is not
bonusy.
key.
Yeah,
tricky.
that's what I do. Okay. All right, if there's no more questions, we're gonna keep on going, because we're all crazy. So we still have to finish up chapter 7. And the normal order of topics students hate that I've noticed over time is word problems is almost always number 1, right? And we've survived those for the most part. They're gonna come back. Anyway, sorry, it's just like a normal supervillain. They come back to the end. Word problems. And then there's like graphing in there. People really hate a lot of stuff about graphing. But then, and then fractions for damn sure, right? Fractions. But that's immediately followed with percentages, right? I feel like people don't understand percentages as well as we used to. because I think they're not teaching the concept as much in lower grades. Like I told you guys, people come and they don't understand what the word of means, which sounds bad, right? But not the English definition of, but the math use of. Right? What do we know of means? Multiply, right? Right, and it only makes sense. If I had 5 apples in a crate and I have 2 of those crates, isn't that 2 times 5?
Yeah.
If I have half of 80, isn't that 1/2 times 80? I like it. So, let me ask you this. What do you guys know? Tell me anything. I am wide open to anything. Tell me anything you know about percentages.
Normally out of 100.
Say again?
They're normally out of 100.
I'm sorry. Oh, out of 100. Okay. I like it. Yes. In fact, when I say cents like this, what does that immediately mean to you? Just cents. Spelled like this, right? Coins. How many cents are in a dollar? 100. Cent is from the Latin centum, which is representative of 100. So per cent literally means per 100. Okay, I like it, so let's file this away. Here's the one big fact right away, is what the shit does the word mean? Yes? And not surprisingly, it goes back to Latin, like a lot of things does. Good old Latin. Anything else you guys know about percentage? Anything, I'm wide open. Anything else about percentages? Surprised nobody's like, I don't like them. Anything, come on guys, any other thing. What's the symbol look like?
Two diagonals.
It's like a diagonal.
Two circles.
And look at this. Isn't percent per 100? What if I take a 0 and I take a 0 and I put the 1 and I put a diagonal? Right? You're like, sure, Jeff, whatever.
Is that where it's
I
coming?
kind of like that. No, it's not really. It's sort of like the division bar. It represents a ratio. Because that's the next thing, is percentages are related to fractions and decimals, right? And we already we didn't see it yet, I don't think. Can't remember. All right, I don't know if I made my question too broad. Where do you guys normally see percentages brought up, besides math class?
At the store.
At the store, related to what?
Sales.
Taxes.
See them at sales, taxes, sure. Discounts, right, and sales. I will say discounts. Could be a senior discount. See it?
Tips. Like
Tips, I love it. So tips.
Weather?
Weddings?
No, weather.
Weather. Oh yeah, okay, for probability.
Yeah.
So weather, I like it. Sorry.
Sorry, it's because I can't.
That's
remember.
right. We're about 72% of the way through the wedding. No, sorry. That's fine. Okay. Any other areas you've run into percentages? All right, you're all like, just drop it, Jeff. We don't know.
In your car, like when you have like an oil percentage left.
Sure, yeah, I love it, right? So you get the oil percent left thing in your car, depending on what kind of car you got. It'll show it to you in several different ways, right? I like it. Now your gas gauge, does it give it to you as a percentage?
No.
But could we convert it to a percentage? Yes, okay, so that's an example of kind of like an indirect percent, because we can make it into a percentage if we wanted to.
Like a
Okay.
region model.
Hmm?
Mine's like a region model.
A region, yeah, exactly, I love it. You're making Math 125 jokes, I love it, yeah.
Is this 7.4?
This is 7.4, yeah, sorry.
You're good.
No, I'm terrible, I'm the worst person. This is something I suck at, by the way. I'll start doing something, and somebody's like, where are we in the book? I have no idea. It's just a neat idea, what the shit. All right. Okay, so they're all over the freaking place. Something that nobody mentioned. Do any of you guys pay attention to, I don't know, elections?
Yeah.
Politics at all? Right? As little as some might be interested in it, we're all affected by it, correct? No, I'm not gonna come at you, yeah, you should vote and blah, blah. right? Not voting is an option you can take. But another place you see this are in like surveys and results of surveys, and we talked to 800 people and 72% said they're gonna vote for this and whatever, right?
Yeah.
So survey results and stuff like that. Or even just, in 2018, 35% of unwed mothers did this, and now it's this percentage, right? Stories about just statistics in general, and you see that all the time. Are you guys kind of with me? Now, I'm not going to suddenly start teaching you statistics, but that's a class everybody should take, because we're so bombarded by these percentages, and very often they are manipulated. They're not lying, they're just telling you a side story. And then you make decisions based on what you think you heard. Anyway, I'll stop. I'm in a very ranty mood, I'm sorry. You guys don't deserve it. Okay. All right, so this is some areas. This is some ideas. So ideas about percentages, what they mean, what the word means. I like we started there. Symbol looks like kind of a neat little connection that's not really, history of it, but still. What they're related to. So we're going to talk about this immediately, is how they're related to this. We're eventually going to do this kind of stuff, but not right away. And of course, this is just always there. Okay, so, have any of you guys ever used a percentage in some way?
Yeah.
Yes. Like in what situation? Probably, some of us probably in this situation here, right? Not really this situation normally, because that's normally kind of calculated for us in tables and such. Right?
Tips.
Tips, I like it. You see some
Weather.
people with a tip calculator. There's a calculator specifically for tips, and I'm always like blown away. I'm like, what that's just a calculator. Anybody ever survive on tips and have a shortcut to figure out? I might have asked this before, I can't remember. No? So sometimes I'll have
A shortcut to say how much.
shortcut to figure out 15% of something.
Yeah, so
I think
my
we did this
shortcut for
before.
20% was
20%, okay.
either doubling the amount and then
Moving the decimal.
moving the decimal,
I like it.
or 10% is pretty easy. Just pretty much
Yeah,
move the
10%
decimal
and then
some.
double it. I like
But
it.
then you showed us
The 10 and the 5.
10 and the 5.
I did show you that.
Yeah.
So like if there's an $80 meal and I want to leave 15%, what's 10% of 80?
8.
Right? And again, just so you make sure that you see what you would put in the calculator, well, I would hope you wouldn't need to, but this is what it would look like. 10%. Now look. All right, let me see. Humans made up all numbers, right? The number 2, we made that shit up.
Yeah.
I'm not saying it doesn't mean anything. I'm just saying we made it up. We created it, right? Percentages are really made up shit. They're completely made up. 10%, what number does that really represent? Now this is getting into how percentages relate to decimals.
0.1.
And let's kind of work our way there. 10%, what does percent mean? So 10 per 100. Anytime you see the percent symbol, you can immediately replace it with over 100. And how do you reduce this? You get 1/10, which of course is 0.1. So what's the shortcut then? If percent symbol means per 100, means you divide by 100. And what happens every time I divide by 10? The decimal goes back once, right? So if I'm divided by 100, I move the decimal back twice, because I'm divided by 10 twice. So the shortcut here would be, where's the decimal here? It's right there. Once, twice, 0.1. I like it. So here's 0.1. Of means times. And of course, if I left this as 1/10, it's even easier, right? 1/10 of 80 is just 8. Now the real shortcut is 10% of anything, you just move the decimal back once. Because it is 1/10. Okay, I like it. Some of you guys know that. Some of you guys just learned it. Okay. That's 8. So if 10%, let me write this again. If 10% of 80 is 8, what is 5% of 80? Yeah. Yeah, 4, it's gotta be, right? It's half. So then what's 15% of 80? 12. So if somebody left me less than $12 and I think I did a good job serving their table, I'm like, that's shit. Right, you guys with me? Okay. All right. Is it warm in here, or is it just me? Just me? You guys feel that?
You're good. You might have left too little tip.
Oh, well.
Come back to you.
I'm not, I always make sure I tip one. There's one time I left a 0 tip, right? And I did this.
Oh.
Because this guy was a jack. Oh, anyway, I'll stop. Again, ranty day, I'm sorry. Yeah.
What's that, the Mexican restaurant downtown?
No, this is in, DC, way back when. Anyway, I won't tell you that story. Okay. So, we sort of just saw how to go from percent to decimal, right? So if I had 123%, could you tell me what decimal that is? Let's see why it makes sense what it is. What did we just say? How do I convert percent to decimal? Yes, right? Because percent means divide by 100.
Yeah.
Every time I divide by 10, I move back once, so I'm divided by 2, so I move back twice, 1.23. 123% of something. Is that more or less than a whole thing? More. So wouldn't it be one whole thing and something left over, right? So that's why it makes sense that it's one whole thing and 23 hundredths of a thing. Okay, like it. Is there anything wrong with 123%? Could you give 123% of your money to somebody?
No.
Not really, right? You can't physically do it. You have to owe them money. So is there any situation where 123% makes sense? If I said there's a 123% chance of rain tomorrow, does that make sense?
No.
Shit, no. Why does it not make sense?
You're going.
Because 100% means
Guaranteed.
it is definitely going to rain. What would 120? What is 123? It's like, it's so going to rain. They're all going to double. It's going to rain in the next universe over. They're going to be big, giant raindrops. Right? Okay. No. But if I said the company's profit went up by 123%, that makes sense. What if a company's profit went up 100%? What does that mean? Their profit did what? Doubled. If it goes up 100%, you're adding it to itself. Does that make sense? If it goes up 123%, it more than doubled. So that situation makes complete sense. Okay, I like it. I just want to address that now, because sometimes teachers are a little bit too adamant about can't be over 100%. Yeah, it can be. Just depends on the situation, right? Okay. What was my point here? Oh, yeah. So any percent. So what would 8% be as a decimal?
0.08.
Yeah. So now you gotta be careful. You want to go back twice. Once, and then you're like, what? There you go. Twice. So 0.08. I like it. So if you think about your odometer, when you buy a brand new car, I don't know how many of you have managed to do that. I did once. Brand new car, what's the speedometer say? I mean, let's say not before you buy it. Let's say the minute they make it, what's the speedometer show?
Yeah.
Nothing but zeros, correct? So, and then, the reason I'm saying that is there are zeros here. And they really don't need to show up ever, right? Unless I'm in a situation where I gotta go back. Now they gotta show up. Does that make, I might not have even had to say that, but.
Yeah.
Okay. There's zeros everywhere for you. So what about this? What is that as a number? Well, a percent is not a number. It represents a number. So here's the thing about math. Any math process does not give the first shit what it is you're applying the process to. It stays the same no matter what. So the process for going from percent to decimal is I move the decimal
100 back to
twice. So your brain says, oh, he's already so tiny, but too bad. He's gonna get even more tiny.
So it'd be
Moana just came in.
41,000.
1, 2, 3, 4. There. Is that cool? Again, I really want you to understand that. You guys get that? If you guys are cool with this one and this one, you have to be cool with this one because it's the same thing. You move the decimal back twice. 0.0031%. Isn't that a stupid small percent?
Yeah.
So it's going to be a stupider, smaller number. Nothing against you. Right? I love you guys. Yes?
So the reason there's 4 zeros is because of the 2 zeros that are in here?
I'm sorry, say again?
The reason you put 4 zeros
Yes.
in, is that because you added 2 more of these?
Yes, because where was the decimal to begin with? Wasn't it right here?
Mm.
And if I move it back twice, I get those zeros to show up. You guys okay so far? I mean, please let me know if something's not making sense. Okay, this is the time to get all this stuff down. All right. Again, because people really don't like fractions, but percentages are directly after fractions, and they're normally not understood either, or liked. All right, so what about the other way? The other way should be simple enough, maybe. What about 0.13? What would that be as a percentage?
13%.
So that'd be 0.00.
Is it a percent to start with? No. So if I go back to go from percent to decimal, how do I go from decimal to percent? Don't I go forward twice?
Yeah.
Undo what I did, yes? I really want this to make sense. What does that symbol mean? Divide by 100. So when I write a percentage, have I divided by 100 yet? No, because the symbol tells me divide by 100. That's why it makes sense the answer to a percentage is smaller. The decimal number will always be smaller than the percentage number, because the percentage number has not been divided by 100 yet. It's saying, divide this damn thing by 100. And we're like, all right, we will. This, what did I divide by 100 to get this? Bam, bam, 13. Now watch what you can do. Watch this. Decimal, percent. Write those letters in alphabetical order. Right? Ooh, it's amazing. Now watch this. This is cool. If I go from percent to decimal, I move the decimal place that way. You understand what I'm saying? I'm giving you a little tool. Sort of like my left and right. So if you write D, and then you write P, alphabetical order. If you go from percent to decimal, you go that way. If you go from decimal to percent, you go that way. Maybe? Maybe, if you need it, right? So what did we do here? We went from percent to decimal, so we went that way.
Mm.
Do you guys see that? Here I'm going from decimal to percent, so I took the decimal place that way. Yes? Maybe? Now, I want you to notice something. Did I tell you this first? No, I told you that after we did several.
Yeah.
This is the correct way to introduce a shortcut or a method or something, or a way to remember, right? I want it built on why it makes sense, and then here's a quick little way to help you remember, right? Okay. Because too many teachers go right to this shit, and they don't build it on anything. Okay, I like it. Okay, so let's do, so let's talk about fractions now. I gotta bring fractions in this business. How would I convert, here's a nice easy one. If I had 31%, can you make that into a fraction? Percent to fraction is so nice.
31 over 100.
Yeah, because percent means over 100, right? Crazy. Now, what's a little bit freaky? What if I had 7.6%? Let's try to do the same thing, and I'll see if anybody can tell why it's not quite right. That would directly be what? What does this say directly? 7.6 per 100. Is that technically a fraction?
No.
Why not?
Because there's a fraction within the fraction.
There's a decimal, yeah. It's not a ratio of whole numbers.
Right.
So how do I, well, I just do this. multiply by 10, multiply by 10. There you go.
Very neat.
Now you could, how do you make this into a decimal?
Move it twice to the left.
Move it back twice, right? 0.076, what place is this in?
1,000.
Bang! Right? You guys see that? So I could have changed that back to a decimal and bang! Right? So, I mean, they're all connected. Who gives a shit what you do first? Oh, look at Jeff go. Oh, sorry. What was this?
So it's because 0.076 is 76 thousandths. Okay.
Yeah, so you can either go there, bam, 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 or you can go from decimal, bang. Yeah.
Nice.
Yes.
So I know you multiplied 7.6 times 10 to change it into like a whole number. Oh no, because
You
at first it was 1,000. So
Oh yeah, I made it 1,000, but I should have done that. Yeah, good point. I just put a 0 there, and then, yeah. All right, not too bad. So what about the other way? What if I gave you 7/5? Can you make that into a percentage?
Would be like the
Sort of. It's related to the first one.
like 1.23%, or
No, you're overthinking.
well,
If I gave you that fraction, why is that an easy one to make a percent?
No,
it's over.
Because over 100 means percent, right? So 31 over 100 is 31%. A over 100 is A%. Jeff over 100 is Jeff percent, right? Because all you're doing is calling the over 100 a different name. That's all it is. So what do you wish was down here then?
100.
Freaking 100. Well, how do you make 100 down here?
Multiply by
So you get,
140.
which is 140%, right? Replace the over 100 with percent. I really want that clear. That leads directly to the math involved. Percent means per 100, which means divide by 100, which is why all this shit works the way it does. All right, what about this thing? 3/8. There's a couple ways you can do this one. So let me know if you have a method. And imagine this. What if this was a problem where I said you can't use a calculator?
Long division.
You could do long division, totally. There's two other ways you could do it that would be quicker. Maybe it's quicker, I don't know. Isn't this 2 times 2 times 2?
Mm-hmm.
How would you make them tens? How many fives would you have to give it?
Oh,
3. So we multiply by 5 times 5 times 5. That'll be over 10,000. Do you guys know what 5 times 5 times 5 is? 5 cubed?
125.
125 times 3?
375.
375. Good. That's right, we're just going to fractions. And then I can make that a decimal if I wanted to, right? I'm going to percentage. Now here's the neat thing. Let's see if you guys could do this. Do you see what I did? Remember what I did here? To make it a real fraction? What do I want this to be again on the bottom?
100.
I want it to be 100, so can't I just kind of do the opposite thing? That would be 37.5%. Just to remind you guys, long division is an option. You could just do 8 into 3, make it a decimal, it'll be 0.375, and then you make it into a percent, right? Is that cool? You can always do that. Here's another way to do it. What is 3/4? You guys should know what 3/4 is as a percent. Like 1/4 is what? A quarter of something is what percent?
25.
So what's 3/4? 75%. How does 3/8 relate to 3/4? 3/8 is how much of 3/4? Is 3/8 bigger or smaller than 3/4?
Half.
It's half of 3/4. Half of 75. Yeah, it's another way to do it. So there's 3 ways to do it. Okay, I like it. Did any of the 3 ways make sense? If at least one of them made sense, you could do it that way, right? well, 3 just sucked, you gotta tell them something. All right. So let's do this. Here. So we're gonna do the side that says percent group work, right? And we're gonna do the first 2 problems. I keep saying we, but it's gonna be you. I'll come in and do it later. Oh, yeah. This time I'm trying to give you too many.
It was 1 and 2.
So number 1 and number 2, let me see, 2, 4, 6, 8, 10. That's crazy sauce. All right, let's see. I want groups. Cammy, Victoria, you guys work together. JC and Mason, you guys work together. Let's see. Robert and Rachel, you guys work together. Destiny, you guys work together. Juan, okay. And Ryan, you work with Juan. So number 1 and number 2. And then you can look at number 3 if you want to.
8 over 10. Did you get this for the last one?
All right, guys, let's take a look here. Holy crap. 3/5. All right, what did you guys do for 3/5? How'd you make that into anything? All right, good. You could do it. Times 20. So that'd be 60 over 100. Right? Did anybody else multiply by something other than 20? Anybody multiply by 2? Yeah, you can multiply by 2, 6/10. Now go become a decimal, right? But from this, what's the percent? 60%, 11. And then what's the decimal going to be? Yeah, 0.60 officially, but then the O doesn't have to be there, right? Is that cool? 60 hundredths is 60 in the hundredths place, but you know, don't need that 0. So if you got 0.6, you're fine. What about life, the universe, and everything? 42%. So now we start way the hell over there. Look how nice I am. I line these up. Right? So if I'm going to take it to decimal, I'm going to move the decimal back twice because I'm going to do what this symbol says. Divide by 100. I'm going to make it smaller. 0.42. And then, of course, that's easy. And even that's easy here, right? 42 over 100, because that's what that means, and that's what this place means. Okay, so they all have to agree. What's the next one here? Oh yeah, this is some people's favorite problem is this one.
In the, sorry.
Oh, go ahead.
42 hundredths, would we be able to?
Oh yeah, you could reduce it.
Okay.
Here's the funny thing. When I give this kind of problem on a test or something, I say, don't reduce.
Okay.
Because some people know where the fraction button is on the calculator, but it gives you the answer in reduced form.
All the way.
So if I say don't reduce, then they have to kind of do it on their own.
Yeah, right. It'll show you.
But yeah, you could reduce that, but don't worry about reducing in this kind of problem. What's the easiest thing? Well, it doesn't matter. What did you guys do first here? Fraction, percent. What would the fraction be? Why is that pretty straightforward?
97.
Yeah, tenths, hundreds, thousands, 10,000s. Or instead of saying the word, you can go 1, 2, 3, 4, 1, 2, 3, 4 zeros. That kicks ass. Because then it gets kind of millions, 10 millions, 100 million. You know, oh my God. Just count. Yeah.
Yeah.
What about percent? Is it easy to go from fraction to percent in this case? Not really, but I'll show you. You could actually, but how to go from there to percent? What would I do? Move the decimal forward twice. It's kind of funny, our brain does kind of not like that, but again, you could have 1% of something, so you could have 0.97% of something. I like it. Have you guys ever heard particulates per million or parts per million?
Yeah.
So like if I'm drinking soup, if I'm having soup, how much of that soup do I want to be, what do I want to say here? There's certain health requirements that allow certain things to happen. How much of that soup would you like to be, what's something that's not that bad? How much of that soup do you want to be dishwater? 0 would be the greatest, right? But if there's some dishwater in there, wouldn't you want it to be like 1 part per billion or something? Meaning there's 1 particle of dishwater per billion particles of soup. If there had to be some in there, like, we'll make it a freaking giant bottom on that fraction, please. Thank you very much.
Yeah.
So this just means 97 parts per 10,000, right? And that's, you know, that's the soup that's starting to taste a little dishy instead of fishy. All right.
There was a thing with peanut butters.
Peanut butter one?
Like, because it attracts so many rats.
Oh, that's what I was staying away from.
Yeah.
There's so much rat poop allowed legally.
Yeah.
And that's a terrible thing to think about.
I think it's like a full rat. Like the rats would fall into the thing, you know, and get mixed in.
Oh, yeah.
So, yeah, like legally there's only like, you know, 3 rats allowed.
Yeah.
Each bat of peanut butter.
Really?
Yeah, so think about that next time. Don't even ask about hot dogs.
Organic peanut butter. That's
Yeah.
the way to.
Uh-oh.
That's the way to do
Yeah.
it.
So that's why I went for dishwater, but
Yeah.
there's so many.
Dishwashers.
Yeah, it's crazy. What about 8/13%? What would that be as a decimal?
8.13.
Yeah, just back twice. And I have 2 options here, right? This says 813 over 100.
Yeah.
This you could say the same thing, but you can also look at it as 8 and 1300. So I would accept either one of these because it doesn't say improper or proper or mixed or whatever. Yeah. Is that cool so far?
Sure.
And then I gave you one that was sort of related to one we did earlier. 5/8. Now me personally, I know what 1 divided by 8 is. Right? It's not too hard to know what that is. Because we all know what 1 divided by 4 is. You all know it. What's 1/4? 0.25. So what's 1/8? 0.125. Half of that. And isn't this, now stay with me now, isn't this 1/8 more than a half?
Yes.
4/8 is a half, right? This is 1/8 more. So a half is 50%. 1/8 is 12.5%. So 5/8, 62.5%. Right. That's one way to get there. Or you could do the long division thing, which is a nice trick or whatever, right? Right. So either way you do it, you get to 0.625 and 62.5%. Is that cool? Okay. Or understood? It's probably not cool.
That's cool.
Alright, so that's not that terrible, right? That kind of thing, maybe? And I will tell you, if I give you a fraction that doesn't terminate or something, right? I'll tell you how many decimal places to take it to, so you don't go crazy. Or more crazy. What about number 2? So, number 2 is kind of related to probabilities. If there were 3 left-handed people out of 20 people in a room, I could say, what's the probability that I would pick a left-handed person if I pick somebody random, right? It would be the same answer, because probability is directly related to percentage. But how would we say this in English? How many out of how many are left-handed? How would we say it in English? How many out of how many are left-handed? 3 out of 20, right? Isn't that how you'd say that?
Yeah.
It's exactly how you freaking write it, right? 3 out of 20. 3 out of 20. And then you can make that into a percentage easy. Multiply by 5 on top of it, right? Okay, I like it. It's not too bad, right? I mean, I know some of us came in here with various issues with different things. Some of us had issues with fractions, some of us had issues with word problems. Some of us have issues with percentages, right? So I'm not gonna assume you all don't know shit. I'm not gonna assume you all know everything. I'm gonna work off of what you asked me, right? Okay. This should be pretty straightforward. Anyway, one thing that really helped me, remember, I'm the guy who has trouble with left and right still to this day, which is just awesome to admit. But just remembering that the percent number will always be bigger than the decimal number. So have a quick little check after I do a problem. Make sure that's true. Okay. So let's work our way into this next series of things. Now we're going to get into a little bit of a word problem-y area. So a problem like this, what is 11% of 87? This is really straightforward. You shouldn't have to do any weird little shit. Has anybody ever heard of is over of? You guys ever heard of is over of? I'm almost happy that very few of you heard that, to be honest. There's a much better way to do it. But how would you do this question? What would you do? What's 11% of 87? Well, what number is this?
11.
And what does of mean?
Multiply.
And then 87 is 87. 0.87. 9.57. Is that right? I don't know.
Yeah.
Yeah?
Mhm.
Took me too long, I'm tired. Alright, so that kind of problem. We know what of means. The unknown is here, so technically, how can I write this fully? What would you put in place of what in math? What is? So I don't know what it is, so what do we put there in math? Freaking X. What's is?
Equal.
Equals. There. Did we need that there? No. We didn't really need that there. We did the problem, didn't we? And then I came back in later. So why the hell am I bringing that up? Because, what if it said this? 2.3 is, what do you got? That 42% of what? Here's the funny thing. This is basically pseudo math. This is one step away. Somebody's reading an equation. 2.3.
So would it be x equals?
2.3 is, so I'm going to translate directly. I'm going to do that crazy thing. Google has gotten a lot better, but in the beginning it just was word by word, so it just sounded stupid as somebody who spoke the other language. 2.3 is equals 42%, what do I put here?
0.42.
0.42 of multiply by
X.
x. And then how do you solve that for x? Just one step, right? How do you solve that for x? Yeah, and again, the way you look at any equation is, why is my poor little x dude not alone? Stupid 0.42 is bugging him. What's he doing to him? To multiply. So how do I kill him? Divide. Right? This is not a life lesson, buddy. So whatever the hell that is. Yeah, it's probably something gross.
5.476.
Yeah, that's one I would tell you where to round it. Yeah, because it keeps going, right? Yeah. So I'd tell you to round it to the thousands place or something.
The Burley corrections?
Yep, right under the stick. Yeah, right. All right. So finally, the only other kind of problem that would be this direct would be something like 110 is what percent of 55? So can you construct an equation out of that? Now again, those of you that know the is over of thing, if you really like that method, it will work. For some reason, Mr. Algebra teacher here likes this method better, but I'm not saying you have to do it this way.
Thank you.
So you want,
Say that.
so this would be 110 equals x times 55. Yeah, so I should bring back my little dot to mean time, so I get my x to, right? And again, what do I do to get x by itself? Yeah, divide by 55, right? Is that cool? I divide by 55, he dies. And what's 110 divided by 55? 2. Is that the answer?
No.
No, hell no. It's not 2%, right? It's 2, which is what percent?
200%.
Yeah, once, twice, 200%. Too many zeros, geez. Oh. Sorry. Looks terrible. Looks like somebody who doesn't know how to do cursive trying to pretend they know how to do cursive. I'm doing cursive. So. All right. It's not too bad, right? So, okay. So these are the pseudo word problems. These aren't really word problems. They're one step away from an equation. So what does a real percentage word problem look like? Let's see. I don't know how much half gonna look like. Yeah, sure. $16. How much did it cost originally? So the mistake that people make is they'll do 20% of 16 and they'll add it onto 16. Somebody here might have been thinking about doing that. I really want this to make sense. If you weren't thinking about this, can you see, or if you were thinking about this, it is a mistake. If you take 20% of 16 and add it to 16, does that logic kind of make sense? It's wrong, but you can see what they were thinking. Yes, anybody? You guys with me? How did I get to $16 though? What did I take 20% of? How would I do this kind of problem? So if there, let's do a concrete problem here, real quick. So I got a shirt, it costs $25, and it's on sale for 10% off. How would you figure out the sale price? This is the original, 10% discount. What's the sale price? So this is a normal, straightforward, no algebra required problem. Just, you're in a store, 10% off, and you want to know how much it's going to cost, right? How would you do that?
We'd figure out what 25 times 10%, which is.
All right, so you do 10% of 25. I mean, that, you got to figure out how much money are they going to take off. So one big mistake I see, real quick, some students do this. And that's the answer, right? If you're telling me that you're going to take 10% off and you take 10 cents off, well, screw that, right? Do you guys understand? 10% does not mean 0.10. It means 0.10 times something. It's 10% of something. A percentage means nothing unless it's of something. So this is completely crazy. All right, take 10% off that car. Here's your dime. I'm like, well, thanks a lot. So how do I do this? 10% of 25, that's going to be figuring out how much I'm going to take away, and then I'm going to take it away. It's crazy. So what is 10% of 25? Who remembers the shortcut? Bam! 250. So then I would do 25 minus 250.
2250.
The car was trying to answer, I think. It just said yes. I was freaking out. Now, real quick, I want to show you something. Does all that make sense? I mean, this is what we do in the real world. This is real world shit right there. It's not algebra, which is still real world shit, but I understand if you don't believe me. Okay. Now, answer me this. If I took 10% off of something, how much of the price is left? If I take 10% of something away, how much is left? 90%. So I could have done this instead. This is beautiful. There's not a damn thing wrong with this work. Beautiful. But I could have done 0.9 times 25 in the first place. What is 0.9 times 25, please? That's 90% of 25, right? What is 0.9 times 25? Holy Jesus, shit, right? So why does that make sense? Because, Chef, just calm down, dude. Holy Jesus, shit, what was that all about? 10% away from something leaves 90% of it there. That's why there's two mathematical ways to get to the same answer. Which way is quicker? This way. Why? And again, what did I do first here? I subtracted 10% first. So I'm kind of like starting with this number, and then it just goes straight there. Maybe. And again, if you don't like this, you could do that. If you don't like either one of them, too damn bad, right? You gotta pick something. All right, I like it. So coming back to this, now we gotta think backwards. What is it we don't know here? What do we not know?
How was the?
Yeah, the original cost. So I'm gonna call that X. So now we got something to play with. See if you guys can see the shortcut here. If I took 20% of that price and I'm gonna take it off, how much will be left? 80%. So 80%, and I don't need the zero, I'm just gonna do it, of the original price is left. You see how over here, we knew the amount, the percent that was left, and we knew the original price, and we got the sale price. Here, I know the sale price. I don't know the original price. It's the same stupid formula though, isn't it? So how do I solve this for X?
Multiply times.
Divide.
Divide by 0.8. And of course that gives you 20. Yeah, sorry. It sounded like you said point, and I was like waiting, that's not right, but let me see what she said. So 20, yes, okay. So $20. Put them units on there. Now let's see if that makes sense. If the original was $20, what's 20% of 20? Well, what's 10% of 20? 2. So what's 20% of 20? 4. Went the wrong way. And what's 4 away from 20? 16. It works. You can check your work at the end because you would just do what we did over there, right? Maybe? No? Do you guys understand why? All right. Do you understand the reasoning of the person that does 20% of 16 and then adds that to 16? Didn't I start higher and it went down by 20%? So their thought process is, if I just go back up by 20%, I'll get back to where I was. But what did we take 20% of?
The original.
And that was higher. So 20% of 16 added to 16 will never get me all the way back up. Does that make sense? Because I took 20% of the original, which is a higher price. So 20% of 16 is not going to get me all the way back up. It isn't. So if I do this way, 0.2 times 16 is 3.2. I get 1920, and 80 cents is gone. No good. Okay, I like it. Okay, maybe. So you guys, if you haven't tried it yet, do the second number 1 down there, right? So 1A, B, C. And then, try 2 and 3. We'll see if we can do all those. Alright, I'm going to start to catch up to you guys. Fully translated this. What is, I don't know, so put X is equals. 45% would be what? 0.45. And watch what I can do. Everything we learned this semester can be used anytime you want to, right? So if I move this over twice, I can move this back twice, I just did compensation. 2 times 45 is 9. Now why does that make sense, real quick? Why is this a really easy question? 45% of 100. What's 45% of 100? 45. Because that's what percent means. So what's 45% of 200? Twice then. I love it. Okay. So how do I set up this equation here?
72 equals X times 45.
Yes. And then I just do it.
Divide by 45.
And I don't remember. This says round to the thousandth place. I don't know if you need to. What do you get here?
It's 53.
0.53?
Yeah.
Repeating?
Yeah.
Okay. Or if I rounded to the, what would it be if I rounded to the thousandths place? 5353. There's the thousandths place, right? So it would be 0.535.
It was just the threes repeating.
Oh, just the threes repeating.
Yeah.
Try this again. 0.53, which would be 0.53. There's the thousandths place, so 0.533.
Wouldn't it be 53.33%?
Yeah, so you can make that into a percentage, which is a good question. I'll be more specific on the test. You want one in thousands places in decimal or thousands places in, I normally mean thousands places in decimal. So then you make it into a percentage. 2 is, all right, so this one again. 2 is 5% of what? So then I just have to divide by 0.05. And again, you could just multiply top by 100, bottom by 100, so it'll be 200 divided by 5. Or you just put it in the old calculator. Right. So either way you do it, you get
40.
40. Okay. Port number 2, written all over you. So it is. So number 2 is easier than number 3, or the one we did on the board. The tax is $1,600, which is 8% of the cost of the car. So it's one of these problems. 1,600 is 8% of what? You guys see that? So the reason we do these kind of problems is if you have any percentage problem and you can put it in this language, you can set it up. 1,600 is 8% of, I don't know. So what would that equation be? 1,600 is 8% of, I don't know. And then of course you just have to
Divide by.
divide. And again, I can move small ones twice, I can add some zeros, 8 goes into 16 twice, and then 1, 2, 3, 4 zeros. Should be 5 zeros, what did I do wrong? Once twice, was that 1,600? Should be 20,000, right?
Yeah.
What did I do? Once, twice. once, twice. 1, 2, 3, 4. 2. 1, 2, 3. Oh, I did. I just can't count. I'm fine. All right. Yeah, it's really good when the math teacher stops being able to count. It's a good time for him. Is everybody cool with that? After my fumbling around on the zero, $2,000 brand new car. I want that. A laptop. Maybe I don't. To be honest. A laptop. Now this one is one like we did with the hacked. This is a little more complicated because we don't know the original, and I know what it is after a 10% mark up. Oh shit. So this is not a discount. I'm not going to use 90. I'm not going to use 0.9. Right? But I can still do the shortcut. So if I increase it by 10%, what percentage is left after that? You can do it. 110%. Which is what is a decimal? 1.1. So I could do 10% markup would be 1.1 times the original. And that would lead me to the new sale price of $2,002. I really want that, just like the 0.9 we did earlier. Why was it 0.9? Because we subtracted. It was a discount of 10%. Now this is a markup. So instead of 0.9, it goes up to 1.1. Same idea. So how do I solve this? What am I doing? Divide. Like the same thing we do every damn time, Pinky. And then what is this? I think it's 1820, is that right?
Yeah.
All right, I didn't do that in my head, I just remember the answer. Just to let you know, I don't want to be a fake math person. Okay. I like it. So there's percentage stuff, right? A little preview of what's to come, and then I'll let you guys out of here because you're all spoiled. I was out early, and I'm spoiled too. So we'll see what we can do here. Let me reset this. So, chapter 8, we're finally going to get into negative numbers are allowed. So let me see. Do I want to show you that? No, I'll show it to you next time. I got a neat video to show you next time that actually gets into. Have you guys ever heard of imaginary numbers?
Yeah.
Right? What does anyone remember what they are? Like the square root of -1. What number times itself is -1? There's no real number that does that, correct? What's -1 times -1?
1.
What's 1 times 1?
1.
So how can I get -1? I have to use imaginary numbers. Now, since I brought it up real quick, the reason I like to show you this video, it goes further than I needed to, but it just points out the idea of negative numbers themselves. When it was first thought up, people were like, what the shit are you on? What do you mean? If I have 1 apple and you take 3 of my apples, I have -2 apples? What the hell are you talking about, right? Because what did numbers need to be in the early goings of humanity is just a way to count the number of cows you had and whatever, right? So the idea of negatives, what the hell would they do? Now, as students, you guys can probably relate to me. When I was a student, I led a very plastic life. I had kind of a debt that I was carrying with all my student loans and all that. So the idea of a negative number pretty much was necessary to describe parts of my life. Yes? All right. I'm almost certain you guys can agree. So one way we introduce the working with negative numbers is to actually have, like, the negatives are represented by, which one does this do? I think it's red. Let's see. It's kind of cool when I move it. Yeah, I'm pretty sure. So negatives are red. See how it's pointing down? So here I have 3 negatives and then another 5 negatives. So of course, what will the answer be? Yeah, so now I've got 8 negatives. Your build is correct, create 0 pairs. I have no positive chips. So I'm done. So I get -8. Because I can just count, I have -8. So let's do one that's got a mixture. I want a mixture. There we go. So here I've got 3 positives. And then I've got, alright, give me a minute. Then I got 9, just throw them in here, Jeff. Get that one over here. Oh my god, this is exciting. Everybody just, hold on. Does anybody ever, do you guys remember, you guys understand this, and do you guys remember learning it this way? Like, so the idea is, I have 3 positives, 9 negatives. So 3 of them are gonna kill each other. Does that make sense? Because if you have a negative and a positive come together, they kill each other, right? So, and one way to think of it is, if I was 9 foot down a hole and I climbed 3 feet up, where am I?
6 feet down.
6 feet down. If I had $3 and I owe you 9, I give you all my money, how much do I still owe you? $6. There's always a nice physical interpretation of a combination of signed numbers. This one is actually, obviously, we're gonna have manipulatives, right? We're gonna put them together. So if I drag this on top, come here. If I drag you, what's happening here? All right, you wanna move, okay. Why didn't you wanna move? You're gonna move, nah. So I just made my pairs. They kill each other. Oh, yeah, I guess I already did. And now I just 1, 2, 3, 4, 5, 6, negative 6. So can you imagine, again, you gotta think in terms of who you will be teaching and what it will take for them to understand an idea. So whenever I'm showing you something, I'm not saying, I do want you to understand, but you have to also think, oh, how would my students react to this? And they will have these things they can play with, not just on the stupid computer where they look at it, little shit they can play with, right? Little chips, these kill each other, you know, and then they throw them away. Or not. All right, let me think. Yeah, that's plenty. What do you guys think? That's plenty. All right, so next time we'll officially get into chapter 8. That was just a little preview, and I'll show you that cool little video. And there you go. Anytime.